We are here today to talk about embedded printer security features. These features are designed to address today's cybersecurity threats, recognizing that firewalls and device protection only during boot up are not sufficient against the latest hacker strategies and tool sets. It only takes a click on an email or to hit print in an attachment for a malware attack to deploy within the network. And devices like printers are a good place to hide since they are generally not being monitored by security. You may have heard that HP has the world's most secure printers, but do you really understand what these features are doing? It's hard to visualize when everything is happening within the software inside the printer. So today, we're going to demonstrate one of these features called Runtime Intrusion Detection. Think of this like the virus protection software you load on a PC. In this case, the technology is embedded as a standard feature in the printer. Now, ethically, we can't hack a competitor's device, so we're going to use two HP MFPs, one with and one without the feature. We have set up a special computer monitor to watch the activity going on inside the printer's RAM. We are also watching on the control panel for a reaction. We'll start the demo on the device without runtime intrusion detection, but first let's think about what might happen when the attack occurs. The machine might crash, start spewing pages, or the hacker could hold it for ransom or use it as a gateway to the rest of the network. Okay, inject the malware into the printer and we'll see what happens. You can see on the monitor that the malware code has been injected. It's starting to disrupt the memory, and we can see the words kernel stomp. This is indicating that the code is doing something it shouldn't. But notice on the control panel that nothing is happening. And this is actually the worst case scenario. The injected malware is inside the printer and going about its business, and yet no one knows it's happening. Now, let's compare what just happened to the same test on a printer with the runtime intrusion detection feature. On the control panel, you can see the device is at a ready state. Let's inject the malicious code. The control panel shows immediately that an intrusion has been detected. Simultaneously, the machine is sending a syslog error message, which could be set up to feed the organization's threat monitoring system, such as a SIM tool, to alert the security team. You can see the printer is rebooting to clear the memory. This was initiated by the runtime intrusion detection feature. And as the device is rebooting, it will run through a series of checks to see if the core operating software has been modified by the malware. First, HP SureStart checks the BIOS, and if problems are found, it will automatically initiate another reboot to reload the BIOS from a golden copy stored inside the printer's hardware. Next, the firmware will be compared against a whitelist of approved HP-signed versions. These checks happen every time the printer is booted up. Soon, the printer will be back to the same state it was in prior to the attack. There was no disruption to users, no service call, and no need for the IT administrator to be involved. This ability to detect, protect, and automatically recover is unique to HP. Only HP can automatically recover. Others can check, and some can self-heal firmware when their MFP is manually rebooted. But can you imagine what the malware is doing to the device in the meantime? How often are printers really rebooted? For real-world, multi-layered security protections, HP is the only choice.